Ah, crayons. These vibrant, waxy wonders have been the cornerstone of childhood creativity for generations. From coloring outside the lines in kindergarten to mastering the art of shading, crayons are often our first step into the realm of art and imagination. But have you ever stopped to wonder how these colorful sticks are made? Get ready to journey through the fascinating process of crayon making, a world as colorful as the art it inspires. Before we delve into the crayon making process, let's take a quick 1-minute look at its history. History. Originating from the Latin word creta, meaning earth, crayons have been around in various forms for centuries. While ancient civilizations used natural substances like charcoal and chalk, the modern-day crayon is a far cry from its rudimentary ancestors. The modern crayon owes its existence to Edwin Binney and C. Harold Smith, who founded the Binney and Smith Company, now Crayola, in 1903. Initially marketed as dustless chalk for classrooms, these crayons quickly became a household staple. Over the years, advances in technology have led to a variety of crayons, including fabric and watercolor versions, broadening their use beyond simple coloring tasks. Raw materials. You might be surprised to learn that the vibrant crayons you've known since childhood are comprised of just a few simple ingredients. At its core, a crayon is primarily made of paraffin wax, a petroleum byproduct that's odorless and colorless in its natural state. What gives crayons their distinctive colors are pigments, which are carefully measured and blended during the manufacturing process. Additional components like fillers and binding agents are sometimes included to enhance the crayon's durability and drawing properties. Here's a fun fact. Did you know that some crayons are actually made with food-grade waxes and are technically edible? That's right. If you've ever been tempted to take a bite out of those colorful sticks, you wouldn't be the first. However, while they might meet safety standards for consumption, they're far from being gourmet. Now that we've covered the basics, let's dive into how these ingredients are transformed into the crayons we all know and love. Preparation phase. The first step in crayon manufacturing involves preparing the raw materials. Paraffin wax arrives in large slabs or pellets, which are then broken down into smaller pieces to expedite the melting process. Meanwhile, color pigments are measured and readied for blending. Melting and mixing. Secondly, blocks of paraffin wax are placed into specialized melting tanks, where they are heated to a carefully calibrated temperature range of 150 to 175 degrees Fahrenheit or 65 to 80 degrees Celsius. This ensures the wax melts to a smooth, uniform liquid, optimal for blending with pigments. Next, pigments are introduced into the molten wax. These pigments are pre-measured to ensure they achieve the exact shade desired for each crayon. To achieve a consistent hue, pigments are mechanically mixed into the liquid wax until fully integrated. During this phase, temperature and mixing speed are constantly monitored. Any deviation in temperature or incomplete mixing could lead to inconsistent color or texture in the final product. Therefore, precision at this stage is paramount. The goal is to create a perfectly blended mixture of wax and pigment that will not only have a consistent color, but also solidify into a crayon with an even texture, free from any streaks or dull patches. If you enjoyed this colorful exploration so far, please subscribe for more fascinating stories behind everyday objects. Color testing. Once the wax and pigments have been meticulously melted and mixed, it's time for one of the most crucial steps in the production line, color testing. In this stage, small batches are extracted and subjected to rigorous tests to ensure the hue matches the intended shade perfectly. But it's not just about the look. The quality of the color also matters. Tests are run to see how the crayon's color appears on various types of paper and how resistant it is to fading. If a batch fails to meet these high standards, it's back to the drawing board, quite literally. Only once a color is approved does it move to the next stage. Molding. In the molding phase, the pre-approved liquid wax mixture is transported to specialized injection molding machines. These machines use high-grade metal molds engineered to exact dimensions, ensuring each crayon comes out uniform in shape and size. The melted wax is channeled through a series of pipes and valves, calibrated to precisely control the flow rate. Once the liquid wax mixture reaches the molds, it fills them via a system of narrow inlets, ensuring even distribution. As the wax mixture settles into the molds, the cooling process begins almost immediately. The molds themselves are temperature regulated, often being cooled by circulated water or other cooling agents to expedite the solidification of the wax. This is a crucial step, as an optimal cooling rate ensures that the crayons have a uniform texture without air bubbles or cracks. Too fast or too slow, and you risk ending up with an imperfect product. The transition from a liquid to a semi-solid state is carefully monitored. During this time, the crayons start taking their recognizable shape. Quality control measures are stringent at this point. Sensors monitor temperature, pressure, and flow rate to ensure that everything is operating within prescribed limits. Even a minor discrepancy in these variables could compromise the integrity of the crayons, causing them to be misshapen or flawed in texture or color. Therefore, it's not just the shape that's solidifying in this phase, but also the overall quality of the finished product. Did you know that the world record for the largest crayon ever made is simply mind-boggling? It measures an unbelievable 15 feet in length and weighs over a ton. To put that into perspective, this colossal crayon could easily dwarf a small car. Just imagine the kind of gigantic art masterpiece you could create with it. It would probably take an entire classroom of young artists just to lift it. Now that's taking the world of coloring to a whole new level. Cooling after the liquid wax mixture has filled the molds and taken on a semi-solid form. The next crucial step is cooling. This isn't a process that's left to chance. It's meticulously orchestrated in a temperature-controlled environment. The crayons remain in their molds, which are often fitted into cooling racks or directly integrated into temperature-regulated systems. The cooling rate is finely tuned to prevent any imperfections. If the crayons cool too quickly, they may develop cracks or fissures, rendering them unsellable. On the other hand, a cooling process that's too slow can cause the crayons to warp or bend, affecting their final form and function. The temperature is monitored in real time using sensitive thermocouples or other types of temperature sensors. These devices provide instant feedback to a control system that can adjust the cooling parameters as needed. The aim is to reach a uniform cooling rate across the entire batch, ensuring that each crayon hardens evenly and maintains its intended shape and texture. Packaging. Finally, the crayons that have passed all the checks and balances are ready for their grand debut. They are transported to the packaging line, where they'll be sorted into sets, often by color or theme. State-of-the-art machines place each crayon in its designated spot within boxes or plastic cases at speeds that defy the eye. The packaging does more than just hold the crayons. It acts as a barrier to protect them from physical damage and to preserve their quality. After a final quality check to ensure the packaging is secure and all crayons are accounted for, these vibrant tools of creativity are boxed and shipped out, ready to color the world.